Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the second question from the Crawford International Preliminary Exam. Yes, it's an IEP question paper guys. Please do expect a total number of 10 videos since the question paper had 10 questions in total. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write a preliminary exam. And most importantly guys, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do share do help us grow the channel by just subscribing. Okay, consider the following patterns. Okay, we have a pattern 1 has only one hexagon, pattern 2 has only 3 hexagon, pattern 3 has 6 hexagons. And then the fourth pattern will simply be like this. It will be the 3 hexagons, rather the 6 hexagons, and then the 4 other hexagons. Are you together? So the fourth pattern will simply have 10 hexagons in it. So these patterns, guys, they form a quadratic number pattern, such that I'll simply have 1, 3, 6, and 10. And then obviously guys, remember that for my quadratic number pattern, the second difference is the one that is common. Okay, I'll simply have 3 minus 2, that's 2. The difference over there is 3. The difference there is just 4. And then the common difference is just equal to 1. Okay, first question, they want us to write down the number of hexagon in the fourth pattern. The number of hexagon in the fourth pattern, we simply have 10 hexagons. 10 hexagons, okay? And then now they want us to determine the number of hexagons in the nth pattern. Basically, they want us to write down the nth term for this pattern of hexagons. Now, I know that 2a is equal to the second difference, and then 3a plus b is equal to the first term of the first difference, and then a plus b plus c is just equal to the first term of this quadratic equation. So I can simply find a will simply be equal to a half. I know that 3a plus b, 3a plus b is equal to 2. Therefore, b is basically equal to 2 minus 3 over 2. That's just positive 1 over 2, right? And then now I want to calculate the value of c. Remember that a plus b plus c is just equal to the first term of the sequence. A is equal to a half, b is also equal to a half, and then c. I'll end up finding that c is just equal to 0. So therefore the nth term is basically 1 over 2n squared plus 1 over 2n. This is the general term of my sequence. Okay, and then now I'm told to consider the series over there. Né? I'm supposed to calculate the sum of the n terms, or I'm supposed to calculate Sn, which is the sum of n terms. This type of a series, guys, is a geometric series. How do I know that? Because the common ratio, because we have a common ratio, that is 2 divided by 1, this will give us 2. 4 divided by 2, I still have a 2. 8 divided by 2, this will also give me a 2. Are you together? So the next term would have been 16. Because for me to find the preceding terms, I just need to multiply the term by the common ratio. Okay, so for me to find the sum of the n terms, I just need to say Sn is equal to a r to the power n minus 1 all over r minus 1. A is just equal to 1. R, I have 2 to the power n. Okay, and then over there just have 2 minus 1. I'll be left with just 2 to the n minus 1. So this is the sum of the first n terms of that geometric series over there. Okay, and then now we are supposed to prove that Sn, the sum of n terms, is 1 less than Tn plus 1, Tn plus 1, or rather the n plus 1th term. Tn plus 1, okay, I know that Tn is basically equal to Ar. Tn is equal to Ar to the power n minus 1. So therefore, Tn plus 1 is just a to the power n plus 1. I still have a minus 1 there. And hence, Tn plus 1 is basically Ar to the n. Because the ones will subtract one another. Let me write properly there so that you can see. That's Tn plus 1 and the minus 1 over there. Okay, these ones will just subtract one another. I'll be left with Ar to the n. But remember that, guys, I do know the value of both a and r. A is just equal to 1, r is 2. So Tn plus 1 is basically 2 to the power n. But remember, guys, I did calculate Sn. I can therefore conclude that, okay, Sn, since Sn is equal to, okay, let me write it in full. Since the sum of n terms is equal to 2 to the n minus 1, I can therefore conclude that Sn is equal to Tn plus 1 minus 1. Remember that, guys, 2 to the power n is equal to Tn plus 1. So now I have proven that the sum of n terms is basically equal to, the sum of n terms is 1 less than Tn minus 1. This statement, guys, can be written like this. That's how, guys, we're supposed to tackle that question over there. So please, guys, do stay tuned and wait for more videos. Thank you.